give a quick interview or overview of some of the science that is coming out. Stuart mentioned the IPCC. If you have any interest in climate change, you should at least know of this organization. Maybe a show of hands. Who's heard of IPCC? Okay, that's about normal, maybe half. Intergovernmental Panel on Climate Change is a 2,000 scientist panel. They convene every 5 years, and when they convene, they write a report. It's highly anticipated every time it comes out, and there's all kinds of scientific review of global climate change. And so it's available online. I would recommend that you read the summary for policymakers. It's a 30-page review, very similar to the document that we produced at the University of Hawaii for Hawaii. But if you want the full report, it's 300-something pages. Have at it and go for it. It's very technical, but the summary for policymakers tries to digest it and tell you, here's really what you need to know. And they talk about things like degree of confidence and uncertainty. And those are really important terms that people tend to intermix. I'm not going to get into them today, but just know that when you start talking about in terms of uncertainty, the scientific community is absolutely certain about climate change and what's happening. There's a distinction between observations of climate impacts and climate change. Those are inarguable facts that we're seeing. Temperatures increasing, sea levels rising, we have increased methane release around the world. And then there's projections and predictions for the future. That's where the uncertainty comes in. Be sure not to mix your uncertainty into facts, because those are apples and oranges, right? So just know if you hear of uncertainty and degree of confidence, those are usually for the projections for the future. And those are critically important. The IPCC gets into a lot of detail about what degree of confidence do they have on certain statements, and they qualify it in saying, when we say very likely, it's 80 to 90% probability. So if you want to get into the statistics and the details, there it is, IPCC. You can Google IPCC. There's a very nice report. The report just came out last year, so it's relatively new. As Stuart pointed out, and others have pointed out, it doesn't have all the latest and greatest science for a variety of reasons. One of which is their projections for sea level rise are way too low, and they even readily acknowledge that in the report. So going from the global level IPCC, we have the release of the National Climate Assessment. This is in the Obama administration. This just came out last year, and it's as the title suggests, a national assessment of climate change for the United States. And they break it out by region. And I'm proud to let you know that Hawaii, again, a 5-year report, every 5 years, Hawaii is no longer lumped in with Puerto Rico like it was the last report. You might be wondering, wait, aren't those different oceans? Yes, but they considered us island states. So we are now our own district. There's a nice summary here. I won't go through all this, but just know you can Google National Climate Assessment. They have actually an excellent website. It's a very good website, well done. And they talk about Hawaii and the Pacific Islands and what we're expecting. None of this should be new news to you. Oceans are warming, sea levels rising, precipitation's decreasing, trade winds are decreasing. Here we are again with the 100th day this year that we've had no trade winds. It's amazing. So there it is. The National Climate Assessment at a national level breaks it out by region. Drilling down a little more local here, we have what's called the Pacific Island Regional Climate Assessment, the PIRCA. Again, these are all available online. This is a regional climate assessment that a group of individuals and agencies, primarily through the University of Hawaii, but a number of people participated in this. I was part of a team that participated in a series of reports talking about what does the climate change science tell us for the Pacific Islands region, including Hawaii. And most importantly, there's stuff in here you probably all heard, but there's a series of reports. One is the full report is 150 pages long. There's a nice executive summary that kind of digests it for you and tells you here's really in 10 pages what you need to know. And then there's case studies, because a lot of people have been asking, this is really depressing. The so what question, or I should say the so now what, right? Okay, you've got our attention, what do we do? And this is kind of what Stuart was getting to, is the interventions. Well, there's some examples in here in this report on the case studies of what other countries and regions are doing to adapt to climate change. These reports, all of those that I just showed you, do not get into mitigation, with the exception of IPCC talking about cost-benefit analysis of mitigating climate change. And maybe this is a good opportunity to make that distinction between climate adaptation, which is how do we deal with the effects of climate change, how do we change our lifestyle to adapt to what's happening, as opposed to climate mitigation, which is a completely different beast, and that has to do with reducing greenhouse gases. And we haven't been very successful at the mitigation side. We're making some progress on adaptation. There's a lot of research going into sea level rise and different effects and what we might do, but the mitigation side is part of the reason you guys are all here, because you have an interest in this and you want to know what you can do as an individual. So getting even more local, regional now, we have our climate report for Hawaii. That's the one I just mentioned to you that's outside on the front desk. And this is a nice summary. None of this is original science. We did a literature review of the climate science specific to Hawaii. And believe it or not, we just published this about maybe 6 weeks ago. There was no similar document for Hawaii. There's tons of information, an overwhelming amount of scientific climate change information for the globe, for the nation, for the region, but nothing that was specific to Hawaii. So we produced this report out of necessity and has a nice summary in there of what we're expecting to see in Hawaii, what the science is telling us. And in the report, you'll notice it's broken out by ecosystem. So depending on what your interest is, whether it's marine, coastal, terrestrial, or human environment, human-built environment, we talk about the science and the impacts to those systems. We also make a big distinction in the report between observation and projections, and it's broken out that way. So you can be very clear. There's factual observations of climate change, and then there's the projections for what's expected. Again, apples and oranges. Make sure that you're talking apples to apples. So getting a little more local here with what are we doing here in Hawaii, just wanted to point out some initiatives that have just recently been enacted in the state of Hawaii. And if I was giving this talk 6 months ago, I would say, you know, we're talking a lot, but we're not doing anything. But I'm very happy and proud to announce that we now have some action happening on climate change. One of which is what's called Navigating Change. I won't read through all these details, but there is a governor's initiative, former governor's initiative to address climate change through developing an adaptation plan. And there's been a lot of legislative interest here in the state to develop a climate adaptation plan. This was kind of the one of a series of guiding documents that led us to eventually the development of a climate adaptation plan. Yes, does anybody, show of hands, who knows that we just passed a bill to have a climate adaptation plan in the state of Hawaii? Okay, a few of you, that's good. We do have an initiative now, and we're moving towards developing a climate adaptation plan for Hawaii. We're one of a handful, maybe a dozen states in the nation that now have legislatively mandated laws that will require us to do an adaptation plan. This was referred to as Act 83. And what it does, it's going to focus on sea level rise for the first year. And at the end of 2 years, they're going to produce a report, they being the Department of Land and Natural Resources in partnership with the State Office of Planning. They're going to produce a report that talks about here's what sea level rise and other major expected climate impacts look like, and here's what we're going to do to try to address those issues. So this is great news because, again, a year ago I would have said there's a lot of talk and no action, and now we're changing that very quickly. So that's kind of my high level, here's what the science is telling us. I'm a coastal and sea level type researcher, and I wanted to present to you just some introductory statistics and information about sea level rise in Hawaii. And one of those things, you've heard a lot about sea level rise, it's kind of sexy right now. A lot of the funding for climate change is going towards things like sea level rise because it's very intuitive and we can see it. We can see the tide gauges rising, so it's almost inarguable. It is inarguable that it is occurring at a global scale. The question is how high and how fast? That's the billion-dollar question. And what I wanted to show you here in this slide is the way we measure sea level rise is through satellites in orbit. And they bounce a radar signal off the surface of the Earth 24 hours a day. They're just spinning around the Earth. And they measure the long-term change in the average surface of the sea. That long-term change right now, based on a 20-year record, satellites have been doing this for 20 years, is about 3.2 millimeters a year, roughly a foot a century. In my mind, we can adapt to that. That's fine. It's going to be inconvenient. Kailua is going to erode more. Certain areas are going to flood more regularly. We can definitely deal with a foot, maybe even 2 feet. But unfortunately, you'll notice there's a linear trend here. I don't know if you can see my pointer, but there's a linear trend to this 3.2 millimeters a year global average. That linear trend is expected to go exponential in the coming decades. Another way we can measure sea level rise is through tide gauges. And this we have, sorry you can't see, but this we have a much longer record for, maybe 100 years. Global tide gauge records around the world are also showing a very consistent, about 3 millimeters a year upward trend from the late 1800s to the early 2000s. And you'll notice here at the end of the far right-hand side of this chart is that red satellite data, and it overlies perfectly on the 3-year average of the global tide gauge record. And yes, there's a lot of up and down in this record, seasonally and annually, but the overall long-term trend is about 3 millimeters a year. I'm a geologist, so I like to think in terms of, well, put it into context. What does that mean in geologic time? We know that, most of North America was underwater at one point, and we have major changes in sea level. When we came racing out of the last ice age, about 18,000 years ago, sea level was 300 feet lower than it is now. We came racing out with what could be considered catastrophic melting of ice sheets across the globe, and that was approaching 8 or 10 millimeters a year. So we're not there at a catastrophic rate yet, but unfortunately that 3 millimeters a year is expected to go exponential, and it could be 10 or 12 millimeters a year in the next coming 2 to 3 decades. So I'm going to show you a slide here coming up that talks a little bit more, or shows you that it's a non-uniform distribution for sea level rise. It's not like a bathtub where the ocean goes up all at the same time. So, but before I get to that, some of the contributions to sea level, obviously melting of ice is a major contributor to sea level rise globally. That's intuitive, you guys can understand that, and there's a physical limitation to how fast ice can melt. Even if you were to raise temperature 4, 5, 6 degrees centigrade, ice can only melt so fast, and there's physical constraints on how quickly that can melt. But the other thing that is relatively unconstrained is the thermal expansion of the ocean. So as you heat up the ocean, it actually physically expands. And that's thought to be the major driver, the majority, more than 50% of projected sea level rise in the coming 100 years is due to thermal expansion, more so than the melting of ice. The melting of ice is critically important, but the thermal expansion is actually one of the major drivers of that. So some estimates for sea level rise. I just wanted to kind of put it in a chart form because it helps to know that there's not any single number everybody agrees on. There's a lot of literature out there. This is probably one of the most heavily studied climate change science issues that are out there now, sea level rise. A lot of people looking at this from around the world. And you can see that on the far left-hand side, the low estimate of a half a meter by the year 2100 is that IPCC report from 2007. And you can see there's a number of names. Some of you may not recognize some of these names, but a lot of these peer-reviewed authors were also part of that IPCC panel. So not only did they participate in the IPCC, but they produced their own science that they in turn published outside of the IPCC. And that's a range of estimates, anywhere from slightly over 2 meters to less than half a meter. And in yellow here are the most recent US federal reports. So this is something the US government has now embraced. The Army Corps of Engineers produced a circular, and they have a range of estimates for the year 2100. NOAA, the National Oceanographic and Atmospheric Administration, they do National Weather Service, and among others. They have an estimate, it could be as bad as 2.5 meters by the year 2100. And then the IPCC report there on the far right. You notice that there's the year 2100 is a very common benchmark. Nobody's really projecting sea level rise beyond the year 2100. The reason why is the uncertainty gets too large. You lose confidence in your data beyond the year 2100. So whenever you see estimates for sea level rise, the first thing you should ask yourself is, by what year? Because some estimates, like the NOAA estimates, they don't give you a year. They say, we think it could reach 2.5 meters above present sea level, but we're not going to tell you when. Right? So that's a whole nother issue.